The National Geological Screening aims to identify rocks which have the potential to host a geological disposal facility, or GDF. In 1815, William Smith produced the first map of the rocks of England and Wales, and geological maps have been updated by the British Geological Survey ever since. They, however, only show rocks at the surface, and for the GDF, RWM has to have detailed knowledge of the rocks in the depth range of interest between 200 and 1,000 metres below the surface. A starting point for mapping the subsurface is to use two geophysical techniques, gravity and magnetic surveys. We all know about Isaac Newton and gravity. The apple is attracted to the earth by the force of gravity. Although the apple will fall towards the earth anywhere on the planet, the Earth's gravity field is not uniform. It varies depending on what's below the surface. One factor that causes gravitational variation is the density of rock beneath our feet. A cubic metre of sandstone could weigh as little as just over 2 tons, whereas the same volume of a more dense rock like a basalt might reach 3 tons. The differences in rock density can be measured by incredibly sensitive instruments based on the spring balance principle that react to the local gravitational field. They're called gravimeters. When moved over the ground surface, it's possible to spot changes in rocks on a large scale, even when they're buried. Granites, for instance. Major faults can also be identified from gravity surveys, where rocks of strongly differing density are brought into contact with one another. Gravimeters can be carried in planes, and so maps of relative gravity can be made rapidly with survey planes flying at a few hundred metres above the ground. Like gravity, the Earth's magnetic field varies. Local variations are caused by the variations in the magnetic properties of rocks. For example, igneous rocks that have been intruded into sedimentary rocks will have a different magnetic signature as they tend to be richer in metallic elements. Such intrusions can easily be detected by highly sensitive instruments, even instruments carried by planes. These are usually housed on a boom away from the metal components of the plane, often the same plane that is carrying the gravity meter. Just as with the airborne gravity surveys, magnetic mapping can provide an image of the subsurface, and when the two types of survey are combined, major features can be distinguished in the subsurface. RWM are likely to conduct airborne surveys early in the siting process to complement the work of the National Geological Screening.